Not with me, but it's good. Next time I swear that. You have seen him, but you don't remember him. Not well? Can someone take a look at the Java chat so we can get some of the comments channeled in from the remote participants? Roland is online, for example. Justin is online. Perfect, thank you. Minute taker? If we don't take any minutes, then we just repeat the discussions again. We do that anyways. No, but can someone take a few notes? Just important things like major decisions. Ideally, someone who's not the presenter.
I'm going to go.
Okay. What's your name?
Neil.
Neil. What was the question?
Where do I send the minutes off?
To me. Blue sheets are being passed around. So quick status. We have a couple of documents.
We don't have an area to review.
That's okay. We're not in the room. So we have a couple of documents in ISG evaluation. The authorization server metadata is an AD evaluation. The char document, same, so that's good. The native apps document is pretty much in the end of the processing, so there will be an announcement sent fairly soon.
Okay. Test is it? Wow. Okay. I turned it on. Okay. So yeah. So I repeat that authorization server metadata and the char document are in ISG evaluation, and the native apps document is further along, and the announcement will be sent fairly soon. We have one new working group item added to the milestones, which is the mutual TLS profiles document. We discussed it in Chicago, and there was clear interest in working on that topic, so we adopted it, and it's already, I think, version 2 of the document, and we'll talk about it later today. The token exchange and the device flow are in working group last call, but we need more comments, but we're also going to talk about this. Nat, are you here in the room? Whoops, he forgot the OWASP meeting. So when he shows up, he can probably tell us a little bit about the status of the char document, because he was waiting for a revised ID. Are there any other sort of or is there other info on some of the other documents? I don't think so from the authors of the document. No. Authorization server metadata is nothing. You guys are waiting for the ISG to.
Eric to write it up.
Yeah, waiting for write-up. Good. We also met last week, or at least some of us, for our security workshop in Zurich. This was the third workshop we organized in that series. The first one in Darmstadt, the second one in Trier, and this is now the third one. It's an attempt to sort of collaborate and discuss topics with security researchers who have been quite successful in doing a formal analysis of our protocols, and also discussing other security-related techniques. I think while it's labeled as OWASP, I think it's equally applicable to people working on COSI and other security mechanisms, also for IoT. Or we also talked about the formal methods applied with TLS, sort of just broader. It was, again, a very good workshop. The information is uploaded, so you can find slides and papers there. So we talked, as said, about formal analysis that was done in this group at ETH Zurich, but also from the guys in Trier who are now in Stuttgart, the Stuttgart University. We talked about crypto-related attacks. Antonio from Adobe, who had successfully compromised and hacked many OAuth systems, talked about the recent vulnerability discovered with the JWE, which Mike is going to talk about a little later. So that was a good sideway into cryptography. It was quite interesting, elliptic curve cryptography, and he gave us a good tutorial. We also had new ideas on OAuth, and I hope that some of them actually trickled then down into the OAuth working group. Other BCP ideas for implicit flow and etc. And we also had some discussions on what we could do to improve our way of working. I will share some more detailed notes. I haven't had time to do that yet about the workshop itself and point out specific presentations, but it was a really good workshop, and thanks to Thorsten and of course the team in Zurich for putting this together and spending the time to sort of build the agenda, review the papers, review the slides and so on. So it was good. Thanks Thorsten. For today, the first thing we will talk about is the mutual DLS profile. We have the security topics. Thorsten is going to do that. William will speak about the incremental authorization. And then we have the already mentioned web token best current practice document. So that's for today. We have another session. I didn't put it in the slide deck yet. Nat, since you are here now, could you say a few words about the current status of the JAR document, if you go to the microphone? Yes.
All right, so I'm Nat Sakimura of Number Research. I'm one of the editor of the auth-jar document. I think I have applied most all of the remaining comments already, and I also have talked with Mike about the registration of some of the parameters into the IANA registry, and we discussed, and OpenID Connect has actually larger set of things to register, so we thought that it might be a good idea to just do it with OpenID Connect, and we don't touch the auth-jar. That means that we don't have to go through the another IANA review, so it should be.
So can you, for the guys who haven't been closely following the discussions in the ISG, could you explain a little bit on what the type of comments were during the ISG processing and why it took so long? Because the document has been in processing already for a little while.
All right, so the last IESG comments came in April 24th, right? The part of the reason why it was taking long was that it's been a traveling season for both me and John, right? I've been almost always on the road.
No, that's okay, but the document is, of course, there's a transition period between
the other
ISG,
thing,
remember?
the biggest change is that, so one of the most substantial comments which we acquired during the IESG review is that so before we were composing the values in the request object and on the request parameters, right? And we are advising to use something on the request object. But now, due to because of the comment that's saying that it's probably much better to just use what is inside the request object, we decided to do that. Now, as a result, we kind of removed the possibility to add a parameter like scope on the query parameters, right? And that was, I thought that was a good thing, but then we were waiting for some developer feedbacks as well. And the feedback was that some of the implementations are actually using scope as a switch to switch the processings. So it seems to be a good thing to leave the possibility to use that, I mean, possibility to provide scope duplicating or existing as a query parameter, just as a switch. But from the security point of view, just use what is inside the request object. It's just for the convenience. So what I have done is, in the spec, it's clearly saying that it must use the parameters in the request object, right? But it may, and the client may send the parameters in the query as well, just for the backward compatibility or other things.
Got it. Have you submitted the updated version already?
No,
or?
not yet, not yet.
Okay.
So
Maybe you
the
can do
last
that
IANA
now.
stuff was, talks with, I talked about that with Mike just before the lunch.
Yeah.
So,
But it's it might be good to post a mail to the list and to explain some of those changes.
yeah,
I'm sure people are interested.
I'm also, now that we've settled on the IANA stuff, I'm going to push that to the IETF report. The other comment actually was provided by Brian. Actually, that IANA stuff was also provided by Brian, but the other one, which could have been substantial, was that the danger of using request URI. If you don't vet the request URI well and naively fetch the content of request URI, it may pose a DOS attack to the authorization server. So we've also put some comments about that in the security consideration. That's
like looking at like following up from the discussions we had last week, like sort of we have to think about what could implementers get wrong, and it's sometimes very basic things, and so having some additional stronger wording and explaining this.
Right. So the possibility is that the malicious client may point the URI to extremely big file, clogging up the ports, or it could. I just learned it from Brian as well, but it could specify the request and the authorization request URI as a request URI, so it's going to be recursive, right? So that if the authorization server actually doesn't cut off just after first fetch, it may just continue fetching until all the server memory is exhausted. So that kind of thing I have added to the security consideration.
Perfect.
Okay.
Thank you.
Thanks.
Okay. Okay. Any other items I should add to the agenda? Anything? Some agenda bashing? No. Good. Brian, you want? Do you want to use the clicker?
Sure. You guys done? No. Okay. I look forward to it. Thank you. So I always forget if I should introduce myself or not. I usually don't. Brian Campbell from Ping. I'm going to present on the status of the mutual TLS profile for OAuth2. It is now in draft 2 as a working group document. Little picture of Prague here from the last time we were all here. So what is the mutual TLS profile for OAuth? It's basically two things kind of rolled up and together into one. I'm going to give just a little background on it here, hopefully give some context. So it defines mutual TLS client authentication to the token endpoint, as well as a means of doing mutual TLS sender constrained access tokens for protected resource access. And so why are we doing this? The TLS client authentication is something that's been done in practice for a number of different deployments and implementations for a long time. We've never actually written down and spec'd out how to do it, so it's not necessarily interoperable, or at least not referenceable by people that are using it or other profiles that need to do it. Sender constrained access is something that binds what are typically bearer access tokens to the client certificate, so that they're no longer bearer tokens and they can't be replayed or even played the first time by some other entity that doesn't control the private key corresponding to that certificate. I've been told that the banks, particularly European banks, need these for some server-to-server API use cases that are being driven out by some new open banking regulations. This spec, as it is right now, is referenced by FAPI, the financial API working group in the OpenID Foundation in the read and write API security profile as one suitable holder of key mechanism to use with OAuth, which is a requirement of FAFI. And it's also referenced by the Open Banking API security profile. So there's already demand, at least from the standards world, for applications of it. How it works, just real quickly, mutual TLS client authentication, how that works is it's for authentication to the token endpoint. TLS connection is made, which is always required anyway, but is established with mutual client certificate authentication. The client includes the normal client ID HTTP request parameter in all requests to the token endpoint, which allows for easy identification of the client. And the AS is able to use that client ID, look up the client configuration as appropriate, and verify that the certificate established on that channel is the right one for that client. This was done intentionally to allow the trust model to be somewhat open and flexible, because people deploy these sorts of things in a lot of different ways. And with that said, there is some metadata around indicating for support for this and the nature of it, both provided for the client metadata as well as the authorization server metadata. Mutual TLS sender constrained access tokens. They work by associating a hash of the certificate that's presented during authentication to request the access token. So the access token requests the token endpoint, certificate's presented there per the last slide with mutual authentication, and a hash of that certificate is included in the access token itself. Following that, to actually use the access tokens, the TLS connection from the client to any protected resource is also mutually authenticated TLS. And the protected resources then matches the certificate from the TLS connection to the certificate hashed in the access token itself. And if those don't match up, it rejects the request. In order to kind of facilitate this in an interoperable way, at least as interoperable as we can be around standardizing access tokens, there's a new JWT or JOT confirmation method, which is the, I call it the X509 certificate SHA-256 thumbprint confirmation method. Little wordy, but X5T/S256 is shorter, sort of. And this is building on top of RFC 7800, which defines the sort of overall confirmation method structure, and this is the new sort of method underneath the CNF that defines for confirming certificate confirmation. So here's a hash of the certificate, basically included in the access token. This defines the syntax of it using the facilities provided in 7800. And it's not here, but when we were talking about this in the last one, Justin sort of pointed out that there was a lot of, pointed out that there is a lot of talk about using introspection, but there were a lot of assumptions made about how exactly introspection would work in conjunction with just about any holder of key mechanism that weren't clearly specified in the document. And so the latest revision calls that out pretty explicitly. It says that the same data as the JOT confirmation claim is returned in the introspection response, and it's the responsibility of the protected resource to actually do the validation of that. This document now requests registration as CNF, the confirmation claim, as a token introspection response parameter, and just says it's a brief statement that says it has the same semantics and format as the claim of the same name defined in 7800. That's largely to account for, I don't know, maybe it was an oversight, maybe it was just something we recently realized, that you're going to want basically the same kind of data around 7800, both in introspection responses as you would in JOT. And so this draft just sort of, it's not retroactively, but tries to retroactively define the contents of 7800 as being relevant for introspection responses, and then in turn picks up the certificate thumbprint confirmation. And then just, I don't know if you can see it because it's small, an example of each. Here on the left is a JOT confirmation method, and you can see just the CNF, the confirmation method, and then the hash of the client certificate there. And the token introspection response is unsurprisingly very similar, except it's a JSON response on HTTP 200 with the active is true. Otherwise, the claims look the same, and the confirmation method is the same. So as I was working on this and just sort of as a proof of concept to myself, I took a couple of COTS products, an authorization server and a resource server, and utilizing what was already in place around mutual TLS support, not specifically for this profile, but just the ability to set up the two products to require mutual TLS from the client, and some existing configuration and customization hooks around that. I was able to implement end-to-end support for this profile using existing product functionality, which maybe hasn't been entirely stated, but was sort of an implicit requirement of wanting to be able to do this in a way that's easy for products and deployers to do on a very near-term timescale and not requiring major infrastructural changes. And so, no, it's only been just recently adopted as a working group item, but there are a lot of people interested in this work, proceeding with work dependent on this work and moving forward. So I'm hoping to request that we consider taking this into working group last call sometime soon.
So how many of you have read sort of the latest version or one of the earlier iterations since the last IETF meeting? See a few hands, 2, 4, 5, 6. Okay. So, yeah. I hope you have not just written it, but also read it.
Sean Leonard says, I read the draft, good work. I would like to see more algorithm agility for the confirmation method, i.e. more than just SHA-256. Hard coding any algorithm is not safe because once it is cryptanalyzed, implementations will be hard-pressed to move off it. Also, how can the certificate be transmitted with the token if a relying party wants the entire certificate?
As far as cryptographic agility goes, the agility is intended to be implicitly supported in the same mechanism that we support thumbprint agility for certificates in the JWX series, the JWS and JWE, where there's the thumbprint and new hashing algorithms can be defined through basically a new claim name. And the convention following this is just the X5T, which is X509 certificate thumbprint, and then the pound shorthand for whatever the algorithm is. So, you know, at which time SHA-256 is broken, I hope I'm not standing in front of you guys doing the same song and dance when that happens, but if it does happen and need to upgrade, there would be the need to define a new confirmation method under 7800 that defines the hash algorithm to use and just say, hey, it's the same thing, but you hash it with, I don't know what the latest is, SHA-3 super coolness with these parameters.
So in essence, you're saying adding a new algorithm just means registering a new value.
Registering a new confirmation method value. Yeah, that's right.
Well, it would sort of
Microphone.
Sean.
So John Bradley, Ubico. So if somebody registers a new hash algorithm for certificate thumbprints as part of JSON Web Tokens, then that would automatically happen and be usable in the JSON Web Token. Somebody would have to take the extra step of registering it for the introspection endpoint. But in principle, this is as agile as Jose. And we could perhaps put some sentence in there that called that out. I don't know that if somebody wanted to send the entire certificate, then we would have to create it. Somebody could do another extension spec that said this is the confirmation method to do that. But we talked about doing that amongst the authors, and I think it adds to the confusion having too many methods. And the problem is that if you give the resource server the entire certificate, they think that they should do something with that certificate other than just compare it, and they're most likely going to get that wrong. So I'm not keen on passing the entire certificate down as part of this spec. Somebody, if they really wanted it, could
And of course,
register the method.
the certificate is already conveyed during the TLS handshake
Yeah,
anyway, so
yeah,
we don't
those
want to send it twice.
I was going to say
it's
that
not small. Okay.
So
There's-
can I? So Sean, I'm sorry, we're backed up here. Sean said, okay, yeah, another hash algorithm claim name can be defined, but an example would be good, as well as text in the draft that says what you said, define a new confirmation method, etc. And then he says, yeah, I wanted to see how it interacts with the JWT spec, Jose spec, etc. Like, will one upstream registration be sufficient, or will you have to do one specifically for mutual TLS OAuth? And Justin says, if the CNF is registered with all the semantics of JWT for its sub bits, then it should flow through the introspection, right?
The last one, to Justin's point, yes. So at least for confirmation method, a new hash algorithm defined as a new confirmation method would flow through to JWT as well as introspection. If there was a need for new hash algorithms in the Jose layer of things around the JWK thumbprint related pieces or the JWS, JWE thumbprint related headers, those would be separate registrations. As far as being explicit about how to achieve algorithm agility with this method, I think that's a good point, and some text should be added to the draft similar to what's in the other places. I sort of jumped there with the implicit assumption that it could be done, but some clarifying text would definitely be worthwhile. As far as the full certificate, this might come up as well, but there's a number of reasons not to include it. One would be that it's potentially very large. We're working with access tokens here, which are space constrained to some extent. All the parties involved here do have access to the full certificate through the mutual TLS channel. So there's really just the need to have a secure pointer to that in the token itself. And finally, this only provides recommendations on how you might convey the certificate information between the authorization server and resource server, which is how they actually do that is always at the discretion of the two parties involved. So if they really wanted to do a full certificate, they could do that through whatever method they would otherwise do.
Thorsten.
John,
may I?
Thorsten, yes, Europe. I would like to add that as far as I remember, we decided to use the fingerprint because we just want to give the RS the option to verify that the sender of the access token is actually in possession of the certificate. So how the sender actually proves that it really is in possession of the certificate, and the certificate validation is up to the TLS stack.
Yes.
That's very important to point out. So in the resource server is just supposed to fetch the certificate from TLS stack, build the thumbprint, and compare it to the confirmation method in the access token. That's it. I think we more clearly need to spell that out, that no trust chain verification is required, expected, needed, whatever.
May be required.
I got that feedback during the security workshop as well from one of the implementers.
Okay.
Piotr Sikora, Google. I have a question. Did you consider using hash of SPKI, so public key info, instead of the whole certificate, which is what's used in HTTP certificate pinning, which is smaller part, and it allows to the hash stays the same after you reissue that cert for different expiration date and stuff like that.
We considered a lot of different options. The hash of the full certificate seemed like the most straightforward. If at which time a client has to obtain new certificates, basically they'll need to obtain new access tokens, which didn't seem like a particularly burdensome thing, since all OAuth clients are typically in a position to obtain new access tokens through the normal flows anyway. So it's possible, but the certificate hash seems like the most straightforward, most easiest to implement in an interoperable fashion.
It depends what you want to accomplish, because if you hash the whole certificate, you obviously also include, for example, the subject field.
Sure.
And if you otherwise use the same key for multiple different subjects, then I don't know why would you want to use the same, if you reissue the same certificate, why would you want to use the same key? Like, do you have some cases where this actually happens and where it matters?
No, I don't.
Okay. But it's probably worthwhile to think about. It's a good question.
I'm really behind.
Oh, yeah.
So Justin said that was okay for his answer. Sean says some method of retrieval would be helpful. He says if it's available to all, he would like to see text that describes the availability. Some method of retrieval would be helpful, and if it's not in the token, then it has to be stored and referenced, which has downsides. If it's available to all, would like to see the text that describes how, or at least the fact that, all parties have access to the certificate itself.
All right, a couple of cases for SPI hash. Multiple issuers could occur if you're running bridges, for instance. I'm the patron saint of legacy technology today, so I'll talk about PKI bridges. But also if you're doing short-term certificates, right? Reissuing a cert every like 5 days or 90 days, right? Like Let's Encrypt does. You wouldn't necessarily want to do, I know Let's Encrypt doesn't do client today, but they might, right? You wouldn't want to have to reissue your access to those tokens just because you've essentially just refreshed the timer, right? Well, so I think that's a pretty good argument for.
John Bradley, Yubico again. I would take the counter argument that access tokens should probably have around a 5 minute to hour sort of lifetime. And that's what clients do, is refresh them going back to the resource server. So you rotate the certificate, you then make a call to the token endpoint with your new certificate and get a new access token. It's adding extra complexity of having the client try and parse out the SPKI out of the certificate. I think it's putting more burden on the clients, where just doing a hash of the certificate out of that's provided by the TLS stack is probably the maximum that you're going to get a lot of developers to do.
Lucy Lynch. So several times now, people have stated at the mic assumptions, like tokens need to refresh every 5 minutes or whatever. If the draft is based on those assumptions, calling them out in the draft would be good.
Sean Leonard says, I disagree with hashing the SPKI. The relevant security token is the certificate, not the public key. The public key can be extracted from the certificate, not the other way. This also assumes that the cert is available to all parties. I agree with John Bradley just now.
Okay.
Just
one other.
only this time.
Yeah. Brian, would it make sense to add an additional confirmation method that says, for example, in addition to SHA-256, let's say SHA-512, to address some of those comments? Or
I don't think that's necessary.
So the only other thumbprint that we have registered in the specs now is SHA-1, which using SHA-1 as an extra example was not top of mind. Let me put it that way. So if we were going to if we wanted another thumbprint, then probably going back to JOT and actually doing a SHA-3 thumbprint, which nobody's going to support for some decades. But I would rather have Mike register a new thumbprint, since he did the SHA-256 one. We could do a SHA-3 thumbprint that would be ignored but could be used as an example. Now he objects.
Just to clarify, the SHA-1 thumbprint is only defined for JWS, JWE, and JWK. It's not actually applicable here. This just follows the same pattern, but omitted the SHA-1 variant.
Mike Jones, Microsoft. I was just going to make a clarifying point that in the JWS spec, where X5T is defined, it already gives an example of how you would define ones with new hashes. So rather than reproducing that, you could just reference that guidance.
Right, but they're not defined and registered. examples.
Yeah.
I had planned on borrowing wording from the guidance.
Yeah, don't define something just for the purpose of defining it if it's never going to be used.
I wholeheartedly agree. That's why we chose one method that would be secure for the long foreseeable future and easily implementable.
Okay, so there were a couple of reviewers already, and there seem to be a few clarification needed, nothing major, but still an update may be appropriate. Maybe you do even get to that during this week. But I think starting a working group last call doesn't seem to be too far-fetched. Do I have a few reviewers who could do a review during the working group last call? Thorsten, that's good. Did I see your hand, Ned? Thorsten, you also, okay. Yeah.
You're also a working group member, so you can.
Yeah, dual role.
I will.
So anyone who is not also author of the document. Ah, okay, nice. Do you want to? No, it would be nice to have two reviewers who are not the authors of the document, so that we have some solid reviews during the working group last call.
You can detail it to somebody else. It is the sort of thing that you ought to review.
It's pretty short. Do we have a minute taker? Because there were a
Of
lot
course.
there were a lot of comments there that I don't have in my head.
Justin says, I have a client who's implementing this in the near future, so we'll be reading this in depth.
Wonderful.
Okay.
Thank you,
Justin added. Perfect. Thanks, Brian. Or do you have some more stuff?
No.
Oh, okay.
Clock is ticking. The astronomical clock is ticking.
Standing ovations, as usual with your talks. Okay. Thorsten?
And that's why we were joking. John asked me that we do not really stand within the rectangle
What is the
together,
appropriate
right?
social box thing?
Thank you.
I was close.
So,
I broke it.
Malware was successfully installed on your machine? Okay.
Works fine.
So, hi. This is Thorsten from Yes Europe.
John Bradley from Ubico.
We're going to present the current status of the OAuth security topics, BCP. So we've been working several months on the topic of coming up with the best current practice for OAuth security, which in the end is an evolution of the security threat model, which is defined in RFC 6819 and the security consideration sections of RFC 6749 and 50. Before Chicago, we more or less concentrated on how to protect and how to secure the redirect-based flows in OAuth implicit on authorization code grant. And we came up with some recommendations that we presented last time. During Chicago and Prague, we worked on we focused on a different topic, which we're going to present today, which is access token leakage and the different ways access tokens can leak on resource servers. Today, we will be focusing on one specific use case, which is access token phishing by a fake resource server. And this scenario, or this threat angle is really emerging because a lot of people are starting to use OAuth in the context of standard APIs. And in this context, the basic assumptions, the trust model underneath OAuth 2.0 as it had been defined in RFC 6819 is enlarged, or it's no longer to hold. So what's the setup? The setup is a client wants to access a resource server which it exposes to certain standard API. For example, for accessing email, context, calendar data. So for example, the JMAP working group is working on this kind of stuff. And also, it's been mentioned that there is work on open banking APIs across Europe. So also in those cases, clients are going to connect to resource servers that they haven't seen before, which means the relationship is being established at runtime.
Health with the health with FHIR APIs
Yeah.
and such.
Health, electronic signatures, and so on. So these kind of APIs are emerging all over the place, and we have to make sure that security of those use cases and those APIs is ensured. So our assumption is that the client is being configured with the RSS URL at runtime, which in the end means that the trust model is going to change. In the past, the developer got to know the URLs of the resource server and the AS upfront during development time. No, this is going to change. What does this mean? So let's assume the client obtains an access token from the AS, and then the usual invocation happens. So the AS issues an access token, and the client uses that access token to actually invoke a request, a process at a resource server. So fine, so good. But what if the resource server is a bad guy? And the resource server takes the access token, turns around, and just impersonates the client and accesses the legit resource server on behalf of the user, which is perfectly possible because in the end, the client doesn't know whether the resource server it's going to talk to is really the legit resource server for this particular user and this kind of API. So what are our options? And we have sketched out 3 different kinds of countermeasures or classes or categories of countermeasures. And what we would like to do is we would like to present those different categories of countermeasures to you. Some of them or most of them are familiar to the working group members. And we would like to gather your feedback. What do you think should be the best way forward? What the working group should be recommend? What should be documented in the BCP? So one option would be, yeah, let's work with metadata. Let's tell the client where it is safe to use access tokens. This is more or less consistent with the way today cookies are typically handled, because the browser typically only sends the cookie to the origin of the cookie and nowhere else. The AS could publish some information which resource server the AS knows and where it is safe to send the access token to. But the downside is this puts all the burden of ensuring that it's implemented securely to the client and developer. And since this is the large end of the whole ecosystem, we would like to come up with potentially different, more robust ways to do it. Just jump in if you want.
Right. So our experience with OAuth, our experience with OAuth implementers is that this is the sort of thing that they typically get wrong or don't do, which is why it's not really our first preference.
That's right.
It's also hard to test.
That's right. So the second option, also well known to this community, is audience restriction. So in the end, what we can do is we can restrict the access token, the scope of the access token to a certain audience resource server. And in order to cope with that particular threat, we must use an audience that it's bound to the transport. So we can't use a logical audience for just a simple reason. The resource server, for example, if using the HTTP response for the status 401, as it is defined in RC 6750, can just tell the client, oh, please let me mint an access token that is good for calendar, for the calendar server. So this doesn't give any indication which server the client is up to talk to, right? So that's why we think a good way would be to use the URL that the client is sending the access token to as the audience. Alternatively, and this has been pointed out in the workshop in Zurich, we could also use a fingerprint of the TLS certificate. Yeah, which has some merits, I think. Let's talk about that later on. But the point is, the client has to tell the authorization server, hey, please mint me an access token which is good for that specific target. And the AS doesn't need to know whether this resource server is a legit one, right? So on the base level, and I have been told by developers of OAuth products that ASs not necessarily know the RSs that their access tokens are being used for. In the most deployments I'm familiar with, the AS knows all the resource servers, and if that's the case, the AS can do more. We'll come back to that later on.
Right. So there are some objections that have been raised to this in the past. Hi, Justin, where the resource server may be actually split across multiple domains. So there are some edge cases where some people want an access token that would work across a virtual resource server that had multiple routes. So that would have to be something that we would address if we went down this road.
Yeah.
Yes, you could get 2 tokens, but some people don't like that.
I would suggest let's first proceed with our presentation. We will come back to a summary slide where all the countermeasures are being listed, which should serve as a foundation for a discussion. Okay, so let's assume for the moment the client tells the AS where it's going to use the access token. There is a need for a certain parameter to tell the AS. Resource indicators would be one potential options. And then an access token is being created, which is bound to this particular URL. And if the client sends this access token to RSX, and RSX uses the same access token at RS1, surprise, RS1 can validate that the audience in this access token doesn't match to its actual URL and will refuse to process the request. It's fairly simple.
It hit the legitimate server.
Somehow,
no. We have to turn it. No one raised that at the Zurich meeting, so we have to turn it a bit potentially in the direction of the resource server X. That makes more sense, right? Okay, it's funny to have entertaining talks, right? Good. Okay, so if the AS upfront knows that the URL that's being passed by the client does not belong to one of the resource servers that this AS is protecting, then it can just refuse to create an access token, which means that you directly see an error, and this is fail fast. Yeah. Do you want to add something? No. Okay. Good. Yes. Okay. As I said, there are 2 different options. I don't want to dig into the details. We can use the URL, which allows to have a really fine-grained audience, even for a multi-tenant system and so on. The TLS fingerprint would have the advantage that if someone is able to obtain a certificate for the domain of the legit RS, that would be discovered as well, because the access token is bound to the concrete public key. That's why I think it's worth considering. Right. So.
Other issue with the TLS is that in a heavily distributed environment, we may actually have different. In a heavily distributed, Dick Hart, Amazon, in a heavily distributed environment, you may actually have a number of valid TLS certs back in the same resource server. So a fingerprint wouldn't match.
Yeah, but it's something we can consider, but in principle, it would be sticky to whatever. The client would make the call to the resource server and likely would go back to the same, at least the same geographic cluster.
Neil Jenkins.
Then,
the other trouble with the TLS certificate one is if it's a web app, you can't get the TLS certificate out of the browser.
That's the biggest problem with it.
Okay. Could you please take notes, because this is the kind of.
He's the note taker.
Oh, you are the Neil. Oh, Neil, can you just write those pros and cons down? Thank you very much, because that's the reason why we present it. Let's have the discussion afterwards, please. Okay. So because there is another. Yeah, I mean, if we get more time, I mean.
Sure, but nobody else will be in your room.
Okay. So. The third option, and then we can go into the discussion, is proof of possession. That's something we have been working on as a working group for the last couple of years, which means the client, or you call it sender constrained access tokens. So there are different terms. Holder of key is another one, but in the end, the idea is that the client somehow has a key material and is able to demonstrate possession of this key material, and the AS somehow associates the public key of this key material with the access tokens. So do you want to explain that?
Sure. This is essentially the presentation that Brian just gave is one of the ways that one could do this. We're also working on a way of doing it with token binding, but essentially the client obtains a certificate with, or obtains a token proving it's controls a given certificate, gets a access token back, and again makes a TLS connection or a connection which has some sort of applications level signing to resource server X. If you're doing application layer signing, you have to audience restrict whatever it is you've signed, obviously. And then when the bad RS goes to replay it at the good RS, it doesn't have the private key necessary. And since the audience restricted application layer token that you've created, if you're doing it that way, would have the wrong audience, which is similar to the first proposal. The resource server one is going to reject that access token. So our various options for the transport layer are token binding. Yeah.
Okay. So thank you, John. So there are different proposals on the table. Brian just presented the Misha TLS stuff. We also have the token binding, which is underway, which both belong to the same camp, which is the token is somehow bound to the TLS connection. But there are two proposals on the table on the application layer, which is the signed request proposal by Justin, and the JPOP proposal by Ned and John, I think, right? They all have different characteristics, properties, and so on. In the end, and that's the final question, and that's why I want to kickstart the discussion. What should the BCP recommend? I mean, there are a lot of different options, and what I'm hearing from people outside of the working group, there are too many options, right? So, what are we gonna suggest or recommend to people outside there? I have just gave an overview of all the options we just presented, and also about something else if someone has an idea what else we could do. Do you want to add something, or shall we start a discussion?
No, we should just start the discussion.
Not Sakimura and RI, just a clarification. JPOP's half of JPOP actually has been taken to MTLS.
Right. So it would be the
half of JPOP.
Yeah.
Okay. So it's the other half.
Yeah. Let me explain. Yeah. So JPOP initially had the transport side and the application layer side, and this refers to the application side of it. Yeah.
Hey, Annabelle Backman, Amazon. Regarding the audience restriction, 2 comments. I'll echo Justin's concern. We do have use cases where not only do we need to use access tokens with multiple different resource servers, we do not know at the time the access token is requested what the precise origin of those resource servers are. So binding that token to the audience of the resource server would be a problem for us. Again, to echo Dick, the TLS server certificate problem, it's not the case that that's solved by replaying and hitting the same geographic cluster, because even within that you may have multiple server certificates.
May I ask you a question?
Yes.
Why do you need to use the access token on multiple different resource servers? Why there is a need? I would like to understand that.
Mm-hmm. Because getting multiple access tokens is harder.
But it's possible.
It is possible, but it's asking more from implementers. for reasons that are largely opaque to them.
Okay, thanks.
Dirk Balfans, Google. So it seems to me that the two mechanisms here, the two classes of mechanisms that actually address different threat models. It seems like one of them prevents the token to be sent to the wrong receiver, and the other one prevents the token to be used by the wrong client. And really, I think the threat model that you sort of described in the beginning that we're worried about is the latter, where the wrong client is using the token that shouldn't be using the token. And the solutions that prevent the wrong receiver to get the token, just as a side effect, also happen to cover that threat. So the more direct mechanism to address the threat seems to be the one that addresses the wrong client from using the token. So the proof of possession things. Since you were asking, like, oh, there's too many of them, how do we explain which ones to use? If there's a legitimate reason to also address the other threat model, the wrong receiver getting the token, that I think that would then would necessitate the audience restriction mechanisms. And the threat model that is about preventing the wrong client from using the token, I would think the proof of possession mechanisms would go with that.
Thanks.
Descartes, Amazon. So just to confuse you guys, in Amazon we are using audience restriction with URL for a massive deployment, and so we're using that to help solve that problem around how do we prevent somebody that's receiving a token from reusing it somewhere else.
Okay.
So one of the advantages of the audience restriction is that it doesn't require the client to do any new crypto. So while it isn't as necessarily as strong a protection, it has potential deployment advantages in that it might be easier to get client developers to actually do it. Unless we get token binding everywhere, in which case it will be dead easy to do the other.
This is Dirk again. Right, I agree. I just found myself sort of having to think quite a bit more about why this, like, I feel like there's a mechanism that does the audience restriction, but really what we want is we want to make sure that the wrong client isn't getting its hands on the token and using the token. I found myself thinking much more about like why A implies B, why having these audience restrictions actually gives us this property that we want. Like, for example, how do you make sure that the client can't be tricked into asking, you know, for a token that actually refers to the bad server and so forth? Like, there's probably answers to all those questions, but it seems you have to make more so leaps of faith than when you actually address the actual problem you want to address, which is that the wrong client is using it.
Right. With the audience restriction, we're making the assumption that the client can be tricked to ask for a token for the bad guy, but allowing, I mean, that's a different, you know, the user getting access to the bad guy is a different attack than the bad guy getting access to the real resource. So we're trying to prevent the bad guy getting access to the real resource. If the bad guy can completely hijack the rest of the session, they can make their own, you know, they've obviously, to do this, they've already created their own client and got the user to log in, whatever application it is, into their bad resource server. So there's nothing that we can do at this level of the protocol that would actually stop that, because it's just a legitimate OAuth client at that point.
So I think in certain profiles of OAuth, you can ensure that the client binds only to trustworthy resource servers, but it depends on the concrete profile. So for example, in the Mobile Connect use case, there is another trust anchor, which is a discovery service. but we do not know how other profiles are going to use OAuth. So our assumption is that the client can be tricked into accessing a URL which it doesn't know anything about, right?
So not Sakimura Nomura Search again. I just checked the record. I've been preaching for audience restriction back in 2011. And I thought that was a very good solution. Yeah. But actually, since then, I have kind of changed my position because that one's simple and good, but can't solve the problem when legitimate resource server is actually compromised.
That's correct.
So I'm weighing towards sender constraint right now.
I think there are some other merits or pros associated with audience restriction that are bound to this threat, right? So in deployments I have seen in the past, the audience restriction serves the purpose of giving the AS the chance to issue access tokens which only contain the data that the RS is entitled to see, which is a kind of a privacy property. But yes, your comment was completely right. The client has to be aware of that fact, right? So how to get the different access tokens. So in my former life at Deutsche Telekom, we used refresh tokens as the anchor, and then fetched different access tokens for different resource servers based on that refresh token. But it's something that's not specified in the OAuth space, but it can be done within the boundaries of it. Yeah.
I mean, there are other reasons for having the resource indicator. There may be different token types at different resource servers or different claims that you want to put in the access tokens. So people have added this for other reasons. So it happens to also provide a way to do audience restriction, which is useful for this, but it has other useful properties, and you may want to do it even aside from solving this token theft problem. So audience restriction doesn't solve the problem where the token leaks at the authorization server through some misconfiguration, through an intermediate box, exfiltrated from the client, intercepted in other places. It stops the bad client from tricking the bad resource server from tricking the client into creating token for it, but it doesn't solve as many of the possible threats as proof of possession. Yes, Brian, speak.
Brian from Ping. A lot of different thoughts. Let me try to be coherent. I think the leftmost option, AS publishes legit RSs, isn't really a solution. To your point, it puts a lot of requirements on the client itself.
We were being polite.
Okay. And it doesn't, maybe it's already happened, we've kind of taken it out. It doesn't solve the problem of cross-play between the legitimate listed RSs, and it puts a lot of burden on the client that probably won't happen. The audience restriction stuff, there are benefits to indicating where you're going to use it. As you guys have mentioned, potentially varying the content of the access token, varying the keys used, whatever, more or less customizing the access token for the particular resource, as well as being audience restricted. That was the intent of the resource indicators. I'm sorry for the bad name, but that was the name of the draft about a year and a half ago, was to facilitate both of those things. It turns out that it was very controversial because I think a lot of people want to do a lot of different things with it, and the concept of going from a URL or some indicator on the authorization request to an actual audience is it's conceptually sort of easy to think about how you might normalize or generalize that, but it's very, very difficult to write down how to do it in text. So that might be difficult. I think the same problems would exist here, and you get into difficulties of interplay between the authorization endpoint and the token endpoint and using that parameter. I was very interested in the idea of using the TLS server cert because it sort of immediately takes away all of those concerns, but apparently there's deployments where the variance of the cert itself would make it. There's other concerns that come up, so maybe that's not viable. Proof of possession solves the problem, as many have stated, as well as other potential problems of token leakage. Mutual TLS that I just talked about solves it really, really well, but it's a niche deployment kind of thing. It's not, I don't think, widely applicable to the broader ecosystem of OAuth. It's going to be for things like open banking, where there's big moneyed interests and regulatory requirements around the ecosystem. You disagree?
Could you indicate why you think that's a niche?
Deploying mutual TLS is a huge pain in the ass. And under certain constraints or requirements, it can be done, and it solves a lot of problem in those cases. But I don't, because of the pain in the ass factor, I don't think it's going to be anything more than specific sort of niche deployments that it's useful for. Token binding, I think it's great, but it's very early, and it remains to be seen whether it'll be widely available and implementable, and when. Application signing, it seems really simple when you start to think about it and have a solution in mind. It turns out it's really, really hard to get right and do it in an interoperable manner that actually addresses all these problems. I know Justin will say, no, we have it, it works, but it works under the way that he thinks about it and wants it to work, making sure that the right parameters are included in what's signed, what's not signed. Does it protect against this particular threat? What other threats? It's really hard. I've personally gone through that moment of being up in the night and like, oh, I could invent an application signing protocol that would solve all these problems. And after thinking about it, it's not that easy. It's very difficult. So that's my diatribe. I don't know what to do.
You gave us good reasons to not recommend any of those.
Well, there's reasons for all of them, except for the one on the far left. I think there's
Maybe
reasons to use all of them that are useful, but there's also downsides to a lot of them. So in terms of being able to kind of come up with one recommended practice.
Brian, your description sounded like a little bit like maybe the combination of audience restriction and proof of possession is sort of like depending on sort of the pros and cons in different deployments, and in some deployments it may be feasible to just use the proof of possession. Maybe some of it will be easier deployable in the future, while some others sort of can start with an audience restriction. Did I hear that?
Sort of.
No, I'm asking you.
Yeah, I'm
don't
not
know.
sure I was necessarily saying that. I think audience restriction, something to enable audience restriction, is potentially something that could be rolled out sooner to a broader audience because it's sort of just adding an additional parameter, but it would still have to be standardized and deployed. But it's more likely to sort of take place. It turns out it's also, I think, harder to standardize than we think it is. Yes.
Thorsten, just one thought. I mean, all the options listed here are not fully specified. None of those options is captured by an RFC, right? We have some drafts about some of those. So my question is where we focus in the near term, right? We somehow have to decide.
And I don't have an answer. I was
That's okay.
Sharing my thoughts. Having written drafts or considered implementations along the lines of many of these, there's pros and cons of both.
Yeah, it may be that there isn't one perfect solution because we're a toolkit, and the right thing to do for a native app may not be the right thing to do for a server application.
That's also true.
So, if doing mutual TLS is a pain in the ass on the server, it's pain in both asses on a native app. Yes, pain in everyone's ass.
Justin says, I agree with Brian that HTTP signing is limited to places where it makes sense. HTTP isn't simple to deal with. It was never meant to be universal, just useful. I also agree that MTLS is a huge pain in the ass, and we won't see it everywhere either. Why not both?
Right, and Justin should have also pointed out that application layer signing actually is useful for end-to-end, where you may have middle boxes and want to provide security inside the firewall. So there are different use cases that for each of them. Off the top of my head, I think that audience restriction is probably the minimum thing that we could do that actually gets rid of, that's generally deployable and gets rid of sort of 80% of the problems that we're currently seeing. And probably that in combination with other things, depending upon the deployment scenarios. So we have to pick some of these things that we actually turn into RFCs.
So what I heard so far, and I'm sure we have to continue that discussion also on the mailing list. So this is a starting point. But I so far heard at least some of the things that we could get rid of, particularly AS publishing legitimate RSS. I think there was no one sort of arguing for that one, which is at least something. I also heard for the audience restriction, I heard more people arguing against the TLS server certificate fingerprint as opposed to the URL. Did I hear that correctly? Brian
fell in love.
But he's biased.
Okay. Let me utilize that. Brian, shall we sit down and write down a draft for audience restriction, which covers both options, and then have a discussion in the working group, potentially based on resource indicators?
Microphone. Sure. Okay. No, it's okay. I also heard on a proof of possession side, I heard Nat saying that the JPOP part of it actually went into MTLS. So is there not much left from the JPOP?
No, the application signing stuff is still left. The part that we're talking about didn't go.
Okay. Microphone.
The part of JPOP that we're talking about for application level signing, which is similar to but slightly different from Justin's, didn't go into the mutual TLS.
Do you think that's worthwhile to pursue in the future, or is that sort of like, should that be deleted from that list as a sort of not too attractive?
Somebody, not me, needs to choose between Justin's proposal and Nat's proposal for something very similar.
But also, my recollection also was that Justin's proposal didn't found a lot of excitement in the group either. So, like, we were close to axing it.
The problem is application level signing is hard. I don't think that that's necessarily, the fact that nobody wants to deal with it isn't necessarily a reflection on one of the proposals being better than the other.
No,
but they are very similar proposals, so we should probably only do one.
They're very similar, except for all the ways that they're different. In fact, the only thing they have in common is that they're application layer. I did want to maybe just circle back. I do think we should pursue MTLS and token binding as a,
but we are doing that anyway.
Yeah, so I just wanted to clarify. I hope that's not on the table to take them off, but I think they're maybe not sufficient for more immediate needs or wide enough, because MTLS is sort of niche and token binding is at least some period of time away, but they'll solve a lot of problems. But if the group feels like something's needed, some kind of audience restriction, I guess, is the way to go. I'm hesitant, but.
Okay, wrap it up.
Yeah. Thanks for the feedback. I think the wrap up already was given.
Jabber person describing?
Go ahead.
Never mind, I just tuned in as a Jabber. Someone else was saying white. Sorry.
Shall we
Never mind.
go on? Okay. So as Dirk already pointed out, there are, Nat pointed out, so audience restriction, for example, doesn't work for replay on the compromised OS. So there are other related topics we will take a look into. And in the end, we'll try to come up with a subset of recommendations that cover all those different threads in the document, right? So hope in Singapore we will see an update which covers all those topics. Thank you very much.
Okay. This one?
Yeah.
So you have, how much time do we have left? It's still 3. Go ahead. That's fine.
All right, good afternoon, everyone. William Dennis from Google. And today here to introduce a new topic for the working group, which is incremental auth. So the problem statement is the following. Asking for the kitchen sink of OAuth scopes up front is a bad thing. Users should have context of the authorization request. So rather than kind of, jamming 10 scopes at the user at once, you should be giving them this, you should be presenting the authorization request for just the scopes you need when you need them. So for example, granting the calendar scope makes sense in the context of interacting with a calendar related feature. Don't bundle it in with something else. And so I think at
least that's the one you sent to me. When did you send the latest version? This is the one from 11/24. Right. Is that good? Right before lunch?
No, it was after lunch. Maybe it's the next one.
But there's no next. I didn't got a new version.
Right, never mind.
Do you want to send me another one?
No, it's fine. I'm just missing a good image that makes my point. But if you can imagine an OAuth consent screen that has like 10 scopes on it, from calendar to contacts to like YouTube, the sort of kitchen sink of scopes, we still think that's a bad user experience to have all of that at once. And so the definition of incremental authorization then is the ability to request additional scopes in subsequent requests rather than front-loading everything. And importantly, in a way that results in a single authorization grant that represents all the scopes granted so far. The latter part is important. Without that, it's not really incremental. Like, it's just a whole series of separated requests, each with their own scopes. So an important part of the definition is the fact that when it's incremental, you're only tracking one authorization grant that represents the sum of all the scopes granted. So a typical implementation of incremental auth would just display the new scopes. So if you've already granted scope A, and then the app requests scope B, normally the authorization server would only show consent for scope B. And of course, a single refresh token being issued for the union of all those scopes that are granted. Now, this is probably not a completely new concept. OAuth 2 doesn't actually stop you returning an authorization grant with increased scope. And so a lot of people have used that to implement incremental auth. So they increase the scope where they know it's okay to do so, in the sense that the user already granted it previously, so it's sort of okay to bundle in. Right, it's okay to bundle in additional scope on subsequent requests. But that really only works for confidential clients. So if the client is confidential, that's probably a safe technique to use, although it's undocumented. For public clients, native apps in particular, not so much. So as far as Google's concerned, this is definitely something we've been promoting. In fact, recently we've actually started requiring it. So this is an excerpt from the user data policy that basically just says, don't ask for everything up front. Don't try and future-proof. Like, if you think you might have a calendar feature in the future, don't start requesting that today. Just request that when you decide you need it. But as I alluded to, what about public clients? So all the techniques, at least that I've seen so far, and from people who responded on the list, we're all with the confidential clients, where it's you can implement a fairly obvious and fairly safe incremental auth just from the original OAuth spec. So there's no real standard way to do this public clients until now. That's where this draft comes in. It defines the protocol for native app incremental auth, which I called appcremental auth. I apologize. And in addition to defining the profile for public clients, the protocol for public clients, we can also take this opportunity to sort of formalize how it should work for confidential clients. So just because everyone had sort of worked out how to do it, doesn't necessarily mean that it's a bad idea to have some normative text around how you should do it, some security considerations, etc. So the main part of the spec, I think the kind of innovative part of the spec is the native apps, but let's bundle in the confidential clients and document that as well. That was kind of the idea. So how does this appcremental work? The incremental auth for native apps. All right, I'll stop using that term. We added a new token endpoint parameter. This is for during the exchange of the authorization code called existing grant. So when you're exchanging the authorization code from the second or subsequent grants, you actually just include the refresh token from the previous grant using this parameter existing grant. Then when we're issuing the new refresh token, it will actually contain a union of the scope. So this is the sequence diagram. You can see the initial authorization request where we request scope A. We return the authorization code. We then do a token exchange. We get back the access token, refresh token. Sometime later, we decide, maybe we're presenting that calendar feature and we need to increment and request the calendar permission. So in the subsequent request, and this can be repeated as many times as we need, we do a fresh request for scope B. We get the response for scope B. We send the authorization code from that particular grant along with the refresh token from the previous request, and we get back an access token, refresh token with A and B as a union.
Thorsten, just one question. So your assumption is that the AS doesn't know while processing the authorization request whether the user already has granted scope A to this particular client?
That is not the assumption, no. The issue is that because this is a public client, because this is a native app, there's a potential for client impersonation. So while we may know that a user has granted scope A to an app that claimed to be that app, we don't necessarily know it's exactly the same client because it could be impersonated. So
I know basically. So I was wondering whether you could give an indication in the authorization request already, but that would mean potentially to send a refresh token with the authorization request.
Right. I actually have a slide on that.
That's what I would have expected.
I have a slide on that, so we can definitely discuss that.
Okay.
But sort of think of this as like a proof. It's like proof that you already obtained the grant. Maybe I should go over some of the alternative designs because I did actually talk about that. If this question is about that, then.
I just wanted to say that I have seen native apps use the sticky grant pattern, some from large apps who wound up having app impersonation to do privilege escalation later. That if you if you make the assumption that everybody who's installed your app gets the union of all permissions that they've asked for any instance of that app, bad things start happening, which is why this would be an improvement.
Yeah, so I guess maybe it's worth detailing that attack. So the attack goes something like this. You have a popular mail client that has a legitimately obtained grant for the mail scope. And then you have an illegitimate app that presents a, quote, incremental authorization request for some innocent scope. The user approves that. Turns out this client's actually counterfeiting the legitimate mail client, and then they actually get more scope than what the user approved. Whereas if you force them to actually request for the mail scope themselves, for example, the user would hopefully see, geez, why is like this game requiring email access, and hopefully deny it. So that I think is the privilege escalation attack that John was referring to.
So not second normal research, just a question. How do you make sure that the claim by the client saying that it's got the existing grant scope A is actually legit?
So there are some validation checks that you definitely need to do. I have covered that a little bit later.
Okay.
Yeah, maybe I'll get to that, and if you have any questions, then we can cover it.
Just a small clarification, Thorsten speaking. I know about the thread. my question was related to the user experience, the expected user experience. So in the end, if the user already has the app installed, already granted A, then in the subsequent authorization request, the AS cannot really indicate to the user, oh, you already granted A to this client. No, it's asking for another permission. This is like the client would have asked for B only. That's what I would like to know.
I guess as implementation detail, if you wanted to highlight that on the consent screen, you potentially could.
As you already pointed out, you don't know the instance. In order to really identify the instance, you would need to use the refresh token,
right?
Potentially.
Yeah, I guess in the case of Google's authorization server, we don't display that UI, so it wasn't a consideration. But maybe we can add something in. Okay, so Nat, your thing. So as far as implementation details are concerned, like obviously don't just union any two grants and stick them together. We have a few checks in there, so you want to make sure that the existing grant is valid in its own right, so unexpired, unrevoked. And the client ID should match of the two grants. So those are the kind of the two, sorry?
Must match.
Must match. Did that answer your question?
So that's second round Nomura research. So I'm kind of together with Thorsten because it's a public client and it's an unauthenticated client, right?
Right.
So unless you send something like refresh token, you really can't.
Right. So this exists. This is the refresh token that you send.
Okay. Sorry.
So when you do the when you exchange the authorization code from the incremental auth request, you will pass the refresh token from the original request.
Okay, so the existing grant scope A is not saying the scope.
Not the scope string. No, I meant like it's a grant of scope A. Okay, I'm glad I could clarify that. Yeah, yeah. So
yeah,
maybe. But then, yeah. Yeah, and so the theory being, of course, that the client is already in possession of that grant and can use that. So sort of the theory being, well, they've already got permission for that from the refresh token. They've already got permission for the second scope from the authorization code. Then there should be, no. It's sort of a convenience in a way that you're merging them. Right. Okay. So now some alternatives. So we did think about passing the refresh token in the authorization request parameter. Then you can do more nice things on the authorization page. The unfortunate drawback, of course, is putting that token in the GET request, which we never do. So the second alternative is kind of similar in a way. It's just using an access token as a proof of that existing grant. The benefit is that it could apply to more than just the code flow with the refresh token, but the drawback is that it's more susceptible to attack. Like as was covered in the previous talk, these sort of access tokens are going to pass around everywhere potentially, whereas the nice thing about the refresh token is that it only ever gets sent to the token endpoint, and it only ever gets sent on the back channel. And so we're not altering that property here, which I think is nice. I guess like if you want to work on this, we could think of some other ways to solve the UI question. Absolutely, yeah. All right, so some fun news, running code. We actually already implemented this and it's already live on Google's OAuth server. And I have a proof of concept as a client. You can try it out today. It's open source. It's based on the AppAuth library. And I don't know if we can do a YouTube video. It's possible to click that link.
Oh.
This is never been done before, I think.
Probably fail.
At IETF, I don't know. All right. Okay, so here we just did the initial authorization request. So this is for the calendar scope. I'm about to introspect the token there. And you can see that there's one scope listed in the introspection, which is the calendar scope. All right, now this is the incremental auth request, and this is for the blogger scope. User approves that, do the code exchange, and now we're going to introspect the token. And as you can see, there are 2 scopes listed in this token. And you can try this demo out yourself on that GitHub link. Here are the stills here if that was a bit too fast. So, yeah.
This is Jeffrey Yaskin. I saw a second request for to choose which account. Is that actually redundant, and could you avoid it, or is there some reason you have to show it?
Good. You picked up on that. I was hoping no one would notice. Yeah, I think it's a little bit of jank in the demo. Ideally, what you do, since we support OpenID Connect, which has a parameter called login hint, you could actually pass in the hint of the user in that second request to avoid that experience. In other implementations of OAuth which don't support multiple logged in users, you're probably not going to see that problem at all because there's only one user, there's only a concept of one user. So I hope that will fix that jank, and I don't think it should be a big concern for a lot of other people. And yes, anyway, the login hint param can solve that problem.
Torsten, one question just popped up. Do you detect if the user account is different between those requests? Because that might happen.
Yes, I probably should have actually, that is actually one of the things we check. I should amend that slide. So it's the client ID as well as the user. And the fact that the previous grant has to be valid. Yeah. So if anything is different, if different user, different client, anything like that, yeah, you definitely don't want like a Franken token. I don't even know how that would just be weird.
All right, thank you. And Natsakimura, Nomura Research again. 2 questions. So you said you are introducing new parameters, right? Parameter
Yes.
name. Why don't you just, the first question is, why don't you just use refresh token or something like that? Because you're just sending refresh token, right? The other question is that it's really good from the point of view of the collection minimization. You just ask for the scopes when you need.
Right.
But at the same time, it's conceivable that the attacker can actually start asking small scope here and there so that the user doesn't notice that he's actually being profiled, the entire thing. That's a typical spying strategy, by the way. But so the reason why they do that is that it's actually really easy.
Sort of bullying the frog, I guess.
Yeah. To get the full picture. So I suppose I can foresee some pushback from the privacy community as well, unless you kind of address that as well.
Okay. I guess I'm a little surprised to hear that because this is actually like a pro-privacy feature.
This is a pro-privacy, but then it can also.
Well, okay, and if we look at your sort of attack there, where it's like you just like nibble and get like one scope here, one scope there, you don't really need incremental auth to do that. So if you really want, you could just do 10 authorization requests and have 10 grants. And frankly, like if it's an attack that you're doing, that's not like a particularly large barrier. The goal of this incremental auth is more of a developer sort of friendliness thing. Well, one is like we want to promote incremental auth because I believe it's privacy positive. And sort of one way to promote a good practice like that is to make it more developer friendly. And so to make it more developer friendly, we'd like them not to be tracking like 10 different grants. But I'm entirely convinced that this introduces the attack that you mentioned.
So Lucy Lynch, and I have privacy concerns about this, and it appears from your presentation that this is additive, not particularly transparent to the end user that it's additive, and that in order to revoke any one of these things, you would revoke the entire set of permissions and start over as an end user. So say I give permission to access my calendar once, but I want to revoke that, but I've already given permission for mail or something else.
Right.
I would end up not being clear that both things were enabled, and when revoking one, I would revoke them all. Is that correct?
So the actual like revocation of tokens is sort of implementation detail, for better or worse, in OAuth 2. So I think a good implementation is you could piecemeal revoke. That makes sense to me.
Which means that you would have to display to the user every time the scopes that they have allowed.
That's certainly an implementation of the UI.
Somebody turns on and off geolocation all the time for Google Maps.
So I'm not quite sure I follow.
Tell you this is something. Yeah.
Okay, I'm not quite sure I follow. You're talking about revoking, but
revoking some of the scopes granted and
Right.
not others.
that normally doesn't happen during the consent experience. I guess that would normally be the revoke
Right. So
experience.
if this is additive and non-transparent,
Right.
you need a way to signal to the user all the scopes that they've given permission for.
So I think the authorization service could certainly choose to do that in the UI.
So it's the could choose to do that.
Well,
that makes me nervous.
Unfortunately, that whole kind of thing is not defined by OAuth, and so this spec doesn't change that, for better or worse, I guess. The whole. I mean, OAuth doesn't even document revocation, I don't think, as a standard.
No,
it doesn't.
It doesn't. Dick Hart, I'd echo their comments. It's showing what's already been granted and showing what's added, as opposed to, I think, showing that it's all of the things is overloading it, but saying here's what you've already granted and here's a new thing would be.
Right.
I have a little nit on just terminology that auth is ambiguous. And that authorization or auth, to be clear, because at first I was wondering, it wasn't really clear what kind of auth you were talking about.
So the full title is authorization.
Yeah.
Auth Z.
Add a Z on the end, or a Z, depending.
Please. No.
Try to help.
So I think we need a header as well. No, just kidding.
So this is really about discriminating different instances. Oh, John Bradley ping again. This is really about. Sorry, no. Yubico. Okay, cold drugs have finally got me. So this is really more about being able to discriminate instances of apps so that you're providing the right incremental or de-incremental grants to them. So we should. I'm happy to work with you on coming up with a way of using a hash of the refresh token or the session information from OpenID Connect. There's a couple of different ways that you could indicate in the authorization request which instance of the client it is so that you could provide a more fulsome grouping of information. You've already granted these things to this app. Do you want to add this one? And potentially when you go to revoke tokens, you're now going to have different grants for different instances of apps. So we're going to have to look at, do you want to revoke the access to this app for this thing on your iPad versus your Android phone, etc. So there's a few other things around this that probably need to be fleshed out. Happy to work with you.
Great, thank you. I'd look forward to hearing the ideas. Yeah, I think this is another area that's a bit under-specified in OAuth, which is with a native app client, you can potentially have two streams of authorization. And so with incremental auth, you can actually have two streams of that. Like you said, iPad app, iPhone app, one could have calendar permission, one maybe doesn't. And I think that's, again, I think that's a positive thing.
Torsten, I really like your proposal. It solves a problem, a practical problem that we also solved along those lines at Deutsche Telekom. But along the lines that the speakers before me stated, I think the AS needs to have a complete picture of the client instance and should be able to display all the scopes that already have been granted. I mean, it's in the end, it's at the discretion of the AS how to really show this information, but it should be possible. And I'm also not quite sure that really the refresh token should be the end in the object model. So what one could also do, you could have a refresh token or multiple refresh tokens referring to the same authorization grant and so on. So one could implement it in much more sophisticated ways. Not that we have to do that we have done that at Deutsche Telekom that way. So I would also be happy to support that work. So if you like my review or contributions, just
that'd be
drop
fantastic.
me an email.
Thank you.
David Tong says, should a hint not be sent should a hint not be sent in the authorization request that the client is going to apply incremental auth? This will allow the AS to customize consent screen. I agree with not sending a token in the authorization request, but maybe a flag should be sent.
Yep. I feel like it's pretty common feedback now. In addition to a flag, though, it sounds like it could be useful to know exactly what scopes were granted. So a hash of the refresh token could achieve that, or something else. So let's take that as good feedback.
Okay. So we should also cut this now. So how many of you have read this document? This is 0.0 version. Who read it? Not many. So John. Three people. Says
I counted
four.
Plus me.
Of course, plus the author. Thorsten and John, I think you said that you are going to do a review of this one. Was that correct?
And provide our limited insight.
Like normal insight. Okay. Anyone else? Does anyone want? Nat? Very good. Okay. Excellent. So I guess, yeah, thanks. So the code is only available for iOS. So you don't have Android code yet?
It's
yeah, the bar is a little higher here in this working group. You don't have code running in multiple platforms. Forget it. No, just kidding. Thanks, William.
We support our users on whatever platform they happen to be, and I happen to use iOS. So the code is really simple though. You can look at the diff, and it's very small. So if there's demand, happy to port it to Android.
Yeah,
as you can
came
imagine,
across not.
As you can imagine, just one extra parameter on one request. So it's not rocket science.
Well, you've put together for the native app. You've put together so much different libraries and different for different operating systems. So it's sort of like you raised the bar for yourself, unfortunately. Okay.
So I guess it's premature to do a call for adoption.
I think it is, given how many people have read the document. But I sense the
but I guess like
feedback.
The topic seems to be in scope, I guess.
Yeah.
Right.
But we really need more feedback, because otherwise
sounds good.
It gets a little tricky.
So I guess the
PDF version, or do you want the PowerPoint?
All right. I guess the ask is please have a read, and thank you for the reviews. We'll come back to it in a few months.
Yeah. Or of course we can always do that on the mailing list as well.
Hello. I'm Mike Jones from Microsoft, and I'm here to talk about an early draft of a JSON Web Token Best Current Practices document. So when we last met our heroes in Chicago, we discussed a number of reports of JOTs having been implemented and deployed insecurely or incorrectly or both, and discussed ways of preventing confusion between different types of JOTs that might otherwise arise. Hearing all this discussion, among others, Kathleen Moriarty had suggested that we write a best current practices document for JOTs, motivated in part because JOTs are starting to be used by a number of different projects and working groups in the IETF, which is a sign of success, but it means that those that were involved in developing it aren't actually probably even present in many of the discussions about how to use it in these new application areas where a BCP could help people writing new apps to do it securely and correctly. So, Yaron Sheffer took the courage of a first draft, which he then shared with Dick and I, and we revised internally a little bit. And about a month ago, we published a 0.0 individual draft, which you can find on the data tracker. Subsequent to that, there were a number of discussions, mostly in the SecEvent working group, that led to discussions of explicit typing for the security event token, but really that would be just an example of explicit typing for a JOT. And so we turned the crank one more time before we got to Prague and defined how to provide explicit typing for any kind of JOT. So the structure of the document, I think, is borrowed a bit from the TLS BCP. And I like the way that Yaron did that there's descriptions of threats and vulnerabilities in one major section, so these whole subsections describing all the problems that we wanted to describe. And then there's a following section with subsections defining a bunch of best practices. And there's links from the problems to the solutions or the mitigations. And it's often one-to-many, so there might be multiple ways that you would mitigate a particular threat. And one of the interesting things about writing a BCP for something that's already in production use in a number of contexts is you have to understand and balance a number of goals. First and foremost, we want the document to provide actionable information promoting the secure implementation of deployments and JOTs. And we want the guidance to be applicable to a broad and growing set of use cases. At the same time, we recognize that not all deployments will choose to do new things, and in fact, not all deployments are going to need to change, but we try to do an analysis of under what circumstances it would be beneficial to change and in what ways. That said, we're also trying to describe ways to keep existing deployments secure, even if the scope of what those deployments are doing might increase. So for instance, if you have an issuer that starts issuing an additional kind of JOT, how do you prevent an attacker from capturing that initial JOT, which was legitimately issued, and trying to pan it off as something that it's not and get unintended consequences. And we try to recognize the costs of changing and hardening existing deployments. And there's a bunch of practical trade-offs like this that I think one of the productive next steps is for people to start to discuss those and look at what we want to do in some specific cases. So one example trade-off that's probably gotten more discussion, primarily again in the security event token world, the SecEvents working group, is this notion of adding explicit typing. Now, in fact, there's already a type header parameter which could always have been used for explicit typing, but it's largely not used in deployments that I'm aware of. So after discussing a number of alternatives, at least the three of us thought, let's just recommend doing that. It's straightforward. You don't have to define a new parameter. And the way that it works, because it's a media type, is you define an application slash, for instance, SecEvent plus JOT media type. And you'll see an example of that in the set spec, which is referenced from the current JOT BCP draft of using that approach to type future JOTs going forward. But we're not currently mandating that existing deployments do this. We want to have, again, actionable information on how to make those trade-offs. Dick is smiling because I forgot in one place to delete already secure because we had an agreement to not talk about it that way. My bad. You're right to laugh at me. But, part of the trade-offs too, and this was always present in the JOT design, is it's designed to be used in some space-constrained environments, including in browser URL contexts as query or fragment parameters, where space is not free and increasing the size of something may actually break the deployment. So the next steps are the obvious ones. We'd like people to review the document. We'd like people to discuss it, and particularly tell us how you think this fits with your use cases, what's going to be valuable to you, what you think you would do differently, etc. We'd like to bring as much sort of application and use case knowledge into the discussion as possible. And at the end of the time here, perhaps we can consider adoption as a working group document, especially in light of the fact that Kathleen wanted us to do this. I'm done.
Are there any comments? Who has read the document? 2, 3, 4, 5,
6, 7.
7, yeah. 8, 9.
10.
Okay.
10.
If I wait a little longer, it will be 20.
Well, that's good for an early draft.
No feedback. So, Brian, you go first.
It's Brian from Ping. I don't know if this is the right form. I did have a few questions. One, I sent to the mailing list about a little bit more guidance around the use of type in nested JOT scenarios.
And as I responded on list, that's an omission, and we should just define the syntax.
And sort of following up on that, I've been really uncomfortable with type just based on how it's defined in the core layer. It's sort of a toothless definition. Did you give any consideration for guidance around doing something similar, maybe with the critical header at the Jose layer to actually give it teeth play against existing protocols that wouldn't know or wouldn't do any validation around type?
In Chicago, again, in the second working group, and in the list prior to that, there was some discussion of that, and there was some concern that not everybody's implementing critical correctly, which isn't an excuse. And it's not clear that having it be a new must-understood claim gives it any more practical teeth than using a field that we already have, and which, an application profile of any JOT is going to have to define what the validation rules are. And so one of the validation rules for new JOTs using this technique would be that you must validate that the type header matches what you expect.
Sure. I was just thinking about sort of retroactively existing application profiles like OpenID Connect, like OAuth tokens, where there's not actually an application profile. That's something that's that would actually take effect on those existing deployments.
Right. Well, of course, one of the trade-offs is crit is designed to break things.
Yep.
And there's a reason it's there, but for an existing deployment, it's unlikely in most cases that implementers would choose to proactively break things unless you've got a whole lot of context.
But that's the whole point of crit, is that a new profile could define the use of crit in such a way that use of that token against an old profile, like an OAuth access token, would break without the old profile having to be explicitly aware of the new profile. That's kind of the state of the problem we're in.
You're right. I misunderstood you. I thought you were suggesting just editing the code and redeploying.
No.
You're talking about new. Okay.
Presuming the actual functionality was implemented, it's a way to protect against the sort of fundamental problem that's come up here. We can talk about it more. I'm not sure it's...
Can you put a paragraph on the list with a suggestion?
Sure.
Well, no, because this is a good idea, and it's been discussed in other contexts. But particularly if OAuth is going to do this work, which we think it's in scope because JOT was done here, then we should make the OAuth people who aren't members of the ID events. And you can forward a message from ID events if it's already captured well.
Yeah, I only sighed thinking about trying to articulate it, but I'll try to look up what I wrote previously and maybe sort of there was some commentary on the BCP that was not responded to, and as I read through it, not being a cryptographer myself, I started to wonder if these are actionable real things or that need to be considered, or if they're just kind of FUD, and it was really hard to tell. Some of the ones specifically that come to mind are people have criticized a lot the potential use of compression inside of JWE as being a leak factor. I don't frankly understand the attack vector. I don't understand Beast and Crime. From what I do understand, I don't think it's legit, but I'd love to have someone smarter than me tell me whether that's true.
It would be probably good to ask the CFRG what they think of that in retrospect.
And other things like potentially deprecating RSA 1.5 encryption. That's been a common criticizing point around the whole area, that maybe this would be the right thing to do.
And it may be, time to write a short draft that does that. Thanks to Sean Turner's feedback when he was AD supervising it, there is a status field in the algorithms list, and we can change that to deprecated. That's a separate thing, but
yeah, just some thoughts. Otherwise, I think it's good, useful work, but more to be done, maybe.
So, on the topic of compression, it's not necessarily the case that compression, so obviously compression leaks information because the length tells you something about the content, assuming you know the dictionary. And so there have been a bunch of papers on this. Some in the adaptive setting, like so a lot of them are in the setting that is B setting, where crime, where the attacker gets to control some of the data, and they don't get to control all the data, and so they basically use the data they send in to see the dictionary, and then basically, since you're co-compressing the attacker's data and the victim's data, then the attacker gets some information about the victim's tag data is. There have also been attacks in settings where the attacker doesn't do this, like the Hooked on Phonics paper out of what is it? I want to say UNC a few years ago, showing you could use packet lengths to measure what people were saying in variable length voice codecs. So it's not necessarily the case that you could never use compression with encryption. It's just like super bad news if you get it wrong. And so generally I think that the appropriate guidance here would be either something on the level of either never do it or only do it if you really know what you're doing, and here is a bunch of pointers. But it is not a generally safe practice. I'm happy to talk more about what the attacks look like if someone wants to, but probably not necessarily here.
Okay, and this is in the notes then, and so we can go act on that afterwards. You're on.
You're on, Jeff, and back to PKCS 1.5. We actually did use the TLS BCP to deprecate or to opinionate about algorithms. So I think it's absolutely legit to do it in this context as well. No need for a separate draft. And PKCS 1.5 is non-controversial by now.
Okay, before we wrap up this session, I would like to get a sense from the folks in this room whether they believe that we should sort of do this work in this group, or whether you opposed to that work. So now, if you think that we should adopt this work that Mike presented. And please tell me if you are opposed to it. Okay, that was a clear yes. I will talk to Echo about whether he sees this also within scope. When we talked about this, it was with Kathleen. And
I think this is clearly in scope for this working group. There may be some technical issue about it not being like in the charter or something, which I can take a look at, but I don't see any problem with it being stuffed in the charter if it's not in the charter now.
Okay, thanks. So I will do the confirmation, or we will do the confirmation on the mailing list as usual, and then yeah, we're good to go.
Okay, thank you all, and I'll look forward to seeing more reviews.
Yeah. So if there's some reviews of this one, I think it's good work also in light of what we discussed at the workshop last week. We talked about one specific attack there, more crypto-related attack. So if you,
Antonio Sanzo and the invalid curve attack.
yeah. So if you want to volunteer, raise your hand. Brian, oh, good.
Your hand floated into the air as if on its own.
Was that a mistake, or you wanted to? Yeah, you don't. Yeah, but what else do you want to do? Okay, yeah, review. Anyone else? You can still read it. Okay, but Brian, that's good. Yeah, thanks for showing up. And next session on Friday morning.
Yes.
It just comes in, it's like, oh my God. I don't think so.
You know you're getting fired for a while. Okay. No surprise there.
Oh, no. Let's you get it. Fine. Oh, refresh.